Okay, good evening, everyone. So, in the last couple of classes, we looked at functions, right? Uh, yeah. So, today, hope this is working. Okay. So, today we will be looking at pointers this week. All right. Okay. So, to understand why we need pointers, so let's continue from functions. All right. As you know, any function, whatever input you give, it makes a copy of it and works on that copy. It does not work on the original, right? So, for instance, if I write a square function, okay, suppose if I want to square a variable, and say I pass some integer. Okay, now suppose I say x equal to x into x, and I say return x. Okay, here the return type is int. Now, if I call this square function inside main, suppose I say y equal to 5, and then I say square of y. Okay, now suppose here I write print y. What will it print? 5. Now I call square function. Okay, so it comes inside. Suppose here I write print x. What will it print? Here. What is x value? I am passing y. So this is 5. I square x. Now if I print x again, what will it print? 25. Now I come out of the function. Now here if I write print y, what will it print? 5 or 25? It will print only 5. It is modifying x inside the function. X is only a copy of y. Modifying x will in no way affect y. Okay? So y will remain whatever it is. This is again, you need to go back to the concept of scope of a variable. All right? Y is being overridden by x as long as it is inside the function. So inside the function only x is visible, y is not visible. So whatever changes you are making to x, they are not visible to main. X is not visible to main. So you are squaring x, adding, subtracting, doing whatever to x, that is not visible to main. Okay, so x is visible only inside the function, y is visible only outside the function. So whatever changes you are making to x, that is being made to the copy of y. X is a copy of y. X is not original y. Okay, simple, fine. Now imagine imagine you have what do you say, you want to kill someone. Okay, you have some serial killer, you want to give supari to that person to kill someone. Now suppose this person's function is to kill, but this person's nature is whatever you give to him, he will first make a copy of it and do on that. He will perform an action on that. So he will not kill the original person. He will make a copy of that person and kill only the copy. Original person will remain. Okay, but that is not doing the job, right? But I have to use this serial killer. I can't do it on my own. Okay, now imagine this serial killer is like a function. You want to call him any number of times you want, as many people as you want to kill. Okay, but the problem with him is he will never kill the original. He will always make a copy and kill that copy. That is of no use to you. Okay. Now, what you do, you can make him perform a different action. Okay. Although he makes a copy of whatever input you give, you can ask him to do something different. Okay. But you can't change the fact that he will always make a copy. That much you can't change. Inside the function, you can change the code a bit, but the fact that whatever you pass to the function will make a copy of it, that you can't change. Okay. Now, given these two facts, that one, the function will always make a copy of whatever you give. Second, you have the freedom to define the function. Okay. Given these two facts, can you kill the original, or can you handle the original input rather than the copy? That is the question. Okay. So the answer for that is in pointers. Okay. So what is a pointer? A pointer is nothing but address of a variable. Okay. So now what we do, rather than giving the person as input to the killer, we give the address of the person as input to the killer. Now, what the killer does, he makes a copy of that address. Okay. But now we will make a small change in the function. He will not kill the input, but he will kill the value being pointed to by the input. Here the input is address, not the person. Okay. Now, the person is original. There is a original address. All the killer is doing is he's making a copy of the address. Okay. Now, whether the address is original or copy does not matter. Both are pointing to the original person. So even with a copy of the address, he can go to the original location where the person is there. And he goes and does his job. Okay. If you give the value itself, it will create a copy of the value and work on the copy. Okay. So rather than giving the value, we will give the address of the variable. Now it will create a copy of the address. Now what we say, okay, whether it is a copy of the address or whether it is the original address, it does not matter. The original address is also pointing to the original value. The copied address is also pointing to the original value. So you go to that location and do your job, whatever it is. Okay. So suppose I have some variable x with value 10 in my RAM. Now say its address is say some 200 something. I'm giving a subscript a to say this number is an address. Okay, to differentiate it from normal variable. Now what I do, I make a, so when we say this is 200, in one sense, this 200 is actually pointing to this location. Okay. Now what I do, I copy this 200 somewhere. I make a copy of this address. So this 200 is stored as a value in some other address. It can be anything. Right now we need not worry. Say it is stored at 450 address. Okay. It does not matter. Now this original 200 is also pointing to this location, and the copied 200 is also pointing to this location only. Okay. Now what I tell the function, you are given an address, you go to this address and square the variable, square the value. Okay. Now you need not worry whether this address is the original address or it is a copied address or something. It does not matter. The point is this address is pointing to the original location. Even if it is a copy of an address, it's pointing to the original location. See, it's something simple. Suppose there is an event, some venue is there. Now that venue is printed in many pamphlets and given to all of you. It is a copy to everyone, but everyone goes to the same venue. No, just because the address is copied in different pamphlet, each of you won't go to different venues, right? Exactly same thing will happen. But if I try to, give a copy of the venue to each of you, each one of you will go to a different venue. So what I do, venue will be same, but the address of the venue will be copied and given to each of you. So you can make any number of copies of the address, but the original venue will remain the same. The location will not be copied. That's all. That is the difference. Okay. Function will necessarily copy whatever you give it. So rather than giving the original value or original venue, I give it its address. So rather than copying the venue, rather than duplicating the venue, it will duplicate the address. But you can deal with duplicate address also as if it is original. It doesn't make a difference to you. Okay. That is the simple crux of pointers. Okay. We will see applications of pointers in a while, but understand the concept of pointer. Pointer is address. Okay. So now, how do I change my function? And okay, first, how do I declare a pointer? Suppose if I want to declare a pointer to an integer, right? So I write int star, say p. Okay, int p is integer, int star p is pointer to an integer. All right. Now this is pointer declaration. Now I want to point it to some location. Okay, but I can't give any number on my own. Okay, the compiler and the OS will decide what that location is. You see, like I mentioned earlier, RAM is like a huge series of elements. There are many cells in the RAM in a sequence. All right, and each one is of 1 byte. Okay, so suppose this address is say 200, this address is 201, 202, and so on. Say this address is 310, something like that. Okay, now each one is 1 byte. Suppose if you store an integer at 201, what it does, it reserves 4 bytes, 201 to 204 to that integer. All right, then after that, so up to 204, this 201 to 204, you store an integer. Suppose you want to store a character after that. So this 205 will be a character, 1 byte. You need only 1 byte for character. So depending on the integer data type, it will allocate so much space. Minimum is 1 byte. So it will either group those bytes or it will leave that byte at byte level. Okay, this much is there. Now these are all addresses of those locations. All right. Now suppose I want to store the address of some variable, right? Suppose I want to, some integer is stored at 201, right? So what I do, this 201 is an address, right? So I will probably store this 201 at some address. Say this address is 310. Okay. So this 201 is an address, which means this 201, this cell is actually pointing to this cell. Okay, so I can store integers. I can also store the address of an integer in another variable. I can store characters. I can also store the address of a character in another variable. But I don't know the exact numbers of these addresses. Okay, I can use the variable name to refer to its address. So what I do, before I use my pointer, before I initialize, before I give a value to my pointer, I have to declare some variable. Suppose I say int x equal to say 10. So this x, let's assume this x is stored here. Okay, now its address is 201. I don't know what its address is. Right now 201 is only an example. In the memory, it's a very big number. I don't know what that number is. So what I do, I say p equal to address of x. How do you specify address of a variable? Put an ampersand. Ampersand of variable will give you the address of that variable. Okay, this address is, I did not bother what exact number this address is. This address is stored in pointer. That much is sufficient for me. I can deal with that. Okay, so this is called pointer initialization. Okay, so again, if you remember, almost all the data types we saw so far, each one of them, you can either separate the declaration and initialization, or you can combine declaration and initialization in one line. Like if you take a variable like int x, you can separate declaration and initialization. Int x in one line, x equal to 10 in another line, or you can combine them as int x equal to 10 in the same line. Or if you consider array also, you can declare and initialize separately, or you can declare and initialize together in the same line. Even if you take function, you can declare and define the function separately, or you can define the function in one go. So almost all the data types, it's up to you. If you want to separate declaration and initialization, you can do that, or if you want to combine them, you can do that. Similarly, for a pointer also, you can separate declaration and initialization like this in 2 lines, or you can combine them in one line. You can say int star p equal to ampersand x. Okay, this is pointer, declaration, and initialization in one line. All right. Now, again, when you separate declaration and initialization and when you combine declaration and initialization, there is a slight difference in, particularly say in the case of arrays. Yeah, mostly arrays you see. Here also there is a slight difference. You notice in the declaration I am saying int star p equal to ampersand x. Okay. But when you separate declaration and initialization, here you should not say star p equal to ampersand x. No. You have to just say p equal to ampersand x. Okay. This is like saying in array, except in the declaration sentence, every time you use a of I, it refers to the index of the array. Only in the declaration sentence, a of n refers to the size of the array. Okay. Similarly, only in the declaration sentence, int star p is telling you p is a pointer. Okay. In all other cases, if you want to use p as a pointer, you should use just p. You should not use star p. Okay. If you want to use star p, there the star means dereferencing. I will come to that in a while. Don't worry. But just notice this difference. If I am separating declaration and initialization, I am writing int star p. It is saying p is an integer pointer. Then I am saying p equal to ampersand x. I am not saying star p equal to ampersand x. Okay. P is an address. It understands that. Okay. But if I am giving both in the same line, then I am declaring p as an integer pointer and I am also assigning value to it both at the same time. So here I am saying int star p equal to ampersand x. Okay. Now, suppose I want to, so before that, let me just give you some minimal terminology. So this ampersand is giving the address of a variable, or it is called the reference operator. Okay. Star will give you the value at an address. This is called dereference operator. Okay, so both are converse operations. If you have a value, you want its address, put an ampersand before it. If you have an address, you want the value located at that, put a star before it. Okay, so you can say if I have a pointer to x, all right, what you do, you put an ampersand before x to get the address pointer value, and from pointer, if you want to reach x, you put a star. Okay, so yeah, I think that's the thing. You put star ptr, you will get x. You put ampersand x, you will get pointer. Fine. Okay. Now let us modify the square function slightly to ensure that earlier when I passed by, it created a copy called x and then modified the text. Now I want y itself to be modified. I don't want to create a copy and then modify that copy. Okay, you remember the function? In the square function, what did we do? Here in the main, I declared a variable y. I passed that variable y to the square function. But what did the square function do? It declared another variable x. I mean, you're passing it as x, and it is playing with that variable x. But x is a copy of y. So whatever you're doing to x, it will not change y. Okay. Now I want to change y itself. All right. So let's change the function slightly. So what I do? I write square. Now to this function, I need to pass not the integer, but the address of the integer. Okay. So I should pass a pointer. Fine. So I'll say int star x. So here, or I'll say int star p, so that it's simple. It's easy for you to remember that p is a pointer. Okay. Now I have the address of my integer, but do I want to square this address or do I want to square the value at this address? I want to square the value at this address. Okay. So suppose if I say p equal to p into p, what will happen? It will square the address. I don't want that. I want to square the value at p. So how do I access the value at p? Star p. So I modify this as star p equal to star p into star p. Okay. This will square the value located at p. Okay. Now I need not return it. I need not give it back because that value is located at its own location. So when the main function goes back and accesses that location, it will find this new value there. Okay. This value came from main function. This location came from main function. Okay. Now I modified the original value. So I again need not return it. Main function anyway has access to this location. So after calling this function, if the main function goes back to this location and sees, it sees the updated value. Okay. So actually I need not return anything. I can just say void here. Okay. Now in the main function, what do I do? So here I declared some variable y equal to 5. Now I need to pass y's address, okay, to square function, not y. Fine. So there are two ways of doing it. One is I first declared some pointer equal to ampersand y, and then I pass that pointer to the function. Okay. Now, so I can write a print statement before calling this function and after calling this function. So here I say print y, and here I can again say print y. Okay. Now here it will print 5. Here it will print 25. All right. Or you can replace these three statements with two statements. You can say, sorry, you can actually replace these two with these two. So you say print y anyway. So okay, let me modify it slightly so that it will be easier for you. Okay, I put it here. I put it here. I change this. Okay, now these two statements you can sort of replace with a single statement that you just directly call the square with what? Star p. It can't be or. Both are not same. It has to be ampersand y. You see, star p is nothing but y. If you are declaring p, if you are assigning address of y to p, and when you do star p, you will get y, not address of y. You have to pass address of y. So either you pass p or you pass ampersand y. Got it? Okay. Now let's just check it. So I write a function square. First, I'll write the normal function. I take some variable x, I square it, okay, and I return it. Fine. In the main, I declared some other variable int y equal to 5. I'll say print y is percentage %b. So what I say, y before calling square function. Now I call square function and I print y after calling square function, okay? And here I say x inside the square function before squaring, then x inside the square function after squaring, okay? Simple. Fine. Now you see, y before calling square function is 5. We declared y as 5. Then we passed y to the square function. Y is copied to x. X before squaring is 5. X after squaring is 25 because it is still inside the function. After it came out, y is not changed. Y is still 5 only. Okay? Fine. Now, what we can do, normally what we do, so since this is a copy, we want to overwrite the original with the copy. So what we do, we return the copy from the function and we assign that value to the original variable. We explicitly do that. So here we say y equal to square y. Okay. Now what will happen? X is squared and that value is returned by the function. And now you are replacing y with that value in the main function. This is one way of doing it. Now y will be 25. Right? You see, now y after calling the square function, it became 25. Earlier, y after calling the square function was still 5. Why? Because you did not assign the result of square to any value. Now, you assign the result of square function to y. So you could replace y. Okay? This is one way. Now, let us pass the address of y. So let us modify the square function. Let us say star p. Okay? Now I say, so let me delete these statements for now. Int y equal to 5, y before calling the square function, and two ways. So first I say int star p equal to address of y, and then I pass. What do I pass? Yeah, I can pass ampersand y, but I declared a pointer. P or star p? I should pass address of y or y? Address of y. I change the function right now. Here also I need to change. Yeah, just a minute. I will change here star p equal to star p into star p. Now I need not return anything. Okay. Now, it should be void. Yeah. Okay. Now, here I declared a pointer to y, which stores the address of y. Now to the function, should I pass y or address of y? Address of y. Okay. So since I am declaring a pointer variable, in terms of this pointer variable, what should I pass? P is address of y or star p is address of y? P is address of y. Star p is y. That is why I said in the declaration statement, don't get confused with star p. So let me put it like this: int star p, and then I say p equal to ampersand y. Okay. So now you understand p is address of y, not star p. Okay. Now do I pass p or star p? P, because I should pass address of y, right? So I say p. All right. Now I am passing address to the square function. It goes inside, and what is it doing? Star p equal to star p into star p. What do we mean? Go to the location of p and square that variable at that location. What is the variable? Y. So go to y's location and replace y with its square. Okay. So now y itself is replaced inside the function. P is not multiplied, right? Star p is multiplied. And that value is stored not in p, in star p only. Okay. Star p is y. So this is equivalent to saying y into y. Y equal to y into y. Fine. Now when you come outside function also, now y is updated automatically. You need not return it. The function changed the original y, not the copy of y. Okay. So now y before calling the function is 5. Y after calling the function will be 25. Okay. Let's see. You see, y before calling the function is 5. Y after calling the function is 25. Got it? Now you can also check that the value of star p is nothing but y. Before calling and after calling, star p will be different. So p is address of y, star p will be y. Fine. So here what I say, print star p before calling square function, that is star p, and here star p after calling square function, that is also star p. Fine. Now it is just to tell you y and star p are same. Okay. So before calling, star p is 5 because y is 5. After calling, star p will be 25 because y is 25. See, y before calling square function is 5. Star p before calling square function is 5. Y after calling square function is 25. Star p also after calling square function is 25 because star p and y are same. That's all. Fine. Yeah. Okay. Yeah, let's do that also. It will print some address, some very large number. That is some address in the RAM. We will not understand anything from that number. Okay. So here I say print the address of y is. So usually, basically address is integer pointer or cat pointer, whatever it is. It's a pointer, but technically it is sort of an integer. Okay. I mean, we can get into more details, void pointer, and then we use percentage %p, all those things, but let's not get confused now. For now, let's use, you can use %d or you can use %u. Okay. But printing the address or a pointer value. Okay. Now, after calling the function also, this address will remain the same. This will not change. Okay. So it may give you a warning saying that %u or %d, it is an integer, but pointer is an integer pointer. So you're giving a wrong format specifier. Ignore that for now. You will see an integer on the screen. Doesn't matter. So it's only a warning. Don't worry. You see now, y is 5. Address of y is some big number. Even if you see, you won't understand anything. It's a big number. Now star p is the value located at this address, that is y itself. So that is 5. And when you pass it to the function, y is becoming 25, star p is becoming 25. Address of y is remaining the same. You see, same numbers here. Before calling, after calling, address is same. Okay. Fine. Any other doubts? Okay. Now let's quickly write a different function. let's write function for swap. Now, you see in the previous case, now you may ask, you see even without pointer, I could update the original value of y. How? I could return a value from the function, and then after I come out of the function, I can store that value in the original variable. So that is one way of overriding the original variable. Fine. But suppose if I have two or more variables, then what to do? A function can always return only one value at a time. It cannot return two or more values at a time. Okay, so something like swapping. I have a function to swap two variables. I give say 10 and 20. Now I want the function to give me 20 and 10. But what happens? If I use a normal function, it takes 10 and 20, it makes copies of them, and it swaps only these copies. The original variables in the main function will still remain 10 and 20 only. They won't become 20 and 10. Now you can say, okay, what if I change these values in the function and I return them and then I store them in the original variables in the main function? But I can't do that because I'm returning two values. I don't have any operation which says, okay, AB equal to swap of AB. No, I can't do that. I can return only one value. I can override only one value, but here two values are there. I can't do anything. But I want to change original variables, not their copies. So I have to pass the pointers of the original variables to the function so that the function directly accesses the original variables and changes them there in their locations and comes out. Now it does not matter whether the function returns anything or not. The original variables are modified. Got it? So again, so swap normal. Actually I won't need int for a swap function because even if I have int, I can return only one integer, but I have two integers to return. So I can't do anything with swap fundamentally. I can only print them if I want inside the function. I can't return anything. Okay. So I say swap. Say normal swap function, it takes two integers, x and y. And then it uses a temporary variable. Say temp equal to x equal to y equal to temp. Okay. Now if I have main function and here I say a comma b, a is 5, b is 10. Okay. Now I say print ab, what will it print? 5 comma 10. Now I call swap function. Okay. Now again I print ab. What will it print? 5 comma 10 only. It will not change original AB. Inside the function, it may print, if you say print xy here it will print 5 comma 10. And again, if you say print xy here it will print 10 comma 5. But this is restricted only to the function. Outside the function, this is not visible, right? So here AB will still be 5 comma 10. Only xy, which are copies of AB, they changed. AB did not change. Okay. So let's first execute this and see. So I'll say void swap int x int y. I say printf x x and y, or I'll say x equal to %b, y equal to %b before swapping x comma y. Okay, so now I say int temp equal to x equal to y equal to 10. Now I say printf x equal to x and y values after swapping. All right. Now I write main and I say int a equal to 5, b equal to 10, and then I print a and b before swapping. Okay. Now I call the swap function with ab. Now I say A and B after swapping. Okay, that's it. Fine. You see, A and B before swapping is 5, 10. A and B after swapping also 5, 10 only. But X and Y, they are inside the function. Before swapping, they are 5, 10. But after swapping, they became 10, 5. Okay, only the copies were swapped. Originals are not swapped. But I want the originals to be swapped. So I modify my code slightly. Asterisk 10. Let's see. Wait. So I change my. I don't need anything to return. My swap function did not return anything. So it will take addresses of A and B, right? So let's say this is int star P1, int star P2. P1 is address of A, P2 is address of B. Okay. Now, do I want to swap the addresses or do I want to swap the values stored at these addresses? Values. So I should deal with star P1, star P2, not P1 and P2. Fine. In the place of X and Y, I should just give star P1, star P2. Okay. So here, what should I write? No, here what was there in the swap? Int temp equal to X. These 3 lines I should write here. How do I write? You are saying star temp. Exactly. Temp is int only. Temp is not a pointer to integer. So temp is an integer which stores star P1. Now star P1 is equal to, very good. Now, very good. Should pat yourselves. That's it. Okay. Now I should modify my main function slightly. I say int A equal to 5, B equal to 10, and then I say int star P1. Again, you should remember the star P1 outside the main function is different from the star P1 inside the, the star P1 in the main function is different from the star P1 in the swap function. The P1 here is different from the P1 there. That is a copy of this P1. Okay. So changing that P1 and P2 will not change this P1 and P2. Okay. Anyway, so I can say int star P1 and star P2, and I can say P1 equal to address of A, P2 equal to address of B. All right. And now I call the swap function. Now I should pass what? Address of A and address of B. Either I can say ampersand A, ampersand B, or in terms of P1 and P2, what should I pass? P1 comma P2, not star. If I pass star P1, star P2, that is equivalent to passing A and B. But I want to pass ampersand A, ampersand B. So I should pass P1 and P2. Okay. Now that's it. Now you print AB. After swapping, you will get 10, 5. Okay. So let's quickly check this. So I modify this as star P1, star P2. Let's remove this for now. Int temp equal to star P1 equal to star P2, and star P2 equal to temp. Fine. Now int A equal to 5, B equal to 10, int star P1 comma star P2, P1 equal to ampersand A, P2 equal to ampersand B. Now I pass swap P1 comma P2. Here I can say A and B before swapping and A and B after swapping. Fine. Simple. Okay. You see, now they are swapped. Before swapping, they are 5 and 10. Now they became 10 and 5. In the previous case, they were not swapped because you are passing A and B. It is copying AB to X and Y. It is swapping only X and Y. AB are remaining as they are. But now you are passing addresses of A and B. So it is going to those addresses and swapping those values. Okay. And even after you come out, you will see the updated values. Fine. Okay. So this is the basic idea of pointers. Any doubts? If at all you want to, suppose if I give a statement like suppose I don't want to swap or anything. Suppose if I give a statement like P1 plus plus. Or forget, let's say star P1 plus plus. What will happen? Yes, the value stored at P1 will be incremented by 1. So A will be incremented by 1. Okay. So this is equivalent to this. Okay. A plus plus. Got it? So we can say printf value of A is %d before incrementing. Here it is after incrementing. Okay. See, A got incremented. Fine. If without star, no, address will also be incremented, but then now P1 will no longer be pointing to A. It will be pointing to something else. It will be pointing to address of some other variable, not A. That's the idea, no? See, let's print addresses of A and B. Printf value of P. Okay, I can say here also value of P before incrementing. This is pointing to address of A. I can also say P1 address of A. Okay, here you can write %d %u. It's okay. Here I will write ampersand A. Okay. Now what I do P1 plus plus. Okay, these two I will modify. Okay. Now you are incrementing P1. See, address of A, say it is 200. That is stored in P1. Now, when I do star P1 plus plus, it goes to address 200. It will see the value. It will see A equal to 5. It will increment it by 1. That becomes 6. Fine. Now, if I increment P1, what will happen? P1, the value in P1 was 200. Now, it will be incremented by the size of the data type. 200 will be incremented by one integer, that is 4 bytes. So it will become 204. But 204 is not the address of A, it is the address of something else. Okay. But when you say ampersand A, address of A only will be printed, that is 200 only. But P1 will become 204. Okay. So let's just check that. So let's, yeah. Okay. Now you see, let's not use %d. Let me use %u. But you know, these are all warnings, not errors. So don't worry. Okay. So now you see, P1's value and A's address both are same before incrementing. What is that? Some ending with 768. Okay. But after incrementing P1 by 1, it got incremented by 4 because it is pointing to an integer. Now P1 became 772, but address of A is still 768 only, which means P1 is now pointing to some other location, not A. Got it? So whenever you increment a pointer by 1, It will not increment by one number. It will increment by one unit of the data type. If the data type is 4 bytes, it will increment by 4. If the data type is 1 byte, it will increment by 1. If the data type is 8 bytes, it will increment by 8. But when you are writing in terms of pointers, you are incrementing by 1 only. If you are incrementing by 2, it will increment by 2 into that data type size. Like that. Okay? All right. Any doubts? So you need to read a lot. Apart from lectures, labs, tutorials, pointers are the most confusing topic, is the most difficult topic in this entire course or any programming language. You need to read a lot and come back to us with doubts. Only then you will understand. Otherwise, when you are listening like this passively, you think you understood. When you start writing, you'll get lost. Okay? Yeah, what's your doubt? Yes. It may go in an infinite chain. Okay. That address is not stored anywhere. That address will be stored if you create an address variable. If you don't create an address variable, that address will not be stored. That's all. Okay. So let's